Uh, Tomorrow, we will have a session by Engineer Hussam Farraj from Abu Dhabi Polytechnic, and he will be doing. Can you see my screen?
Yes, sir.
Yes, we can see it.
So tomorrow, Engineer Hussam Farraj from Abu Dhabi Polytechnic thankfully joined us to give you a session about Fusion 360. It's also a software from Autodesk. On Tuesday at the same timing, Engineer Haider will deliver a session about SolidWorks. And on Wednesday, Engineer Khadij Al-Hafid will deliver a session about CATIA. Then we will have a competition on Thursday. The competition will be open for all, and you can use any CAD software you like from the 4 softwares that you have attended. So, all in all, we will make or we will announce the procedure and the requirements for the competition on Tuesday. As a committee, we decided to announce it on Tuesday, and you will submit up to Thursday. So you will have 2 days in order to submit your CAD software. Even the CAD file, we will put some regulation regarding the CAD file and the topic of the competition. So we will meet on Thursday, and we will decide 3 winners, and we will announce them for the students, first and second and third winners, inshallah. So I hope this will be very useful for you to take an idea about the available CAD softwares in the market. For a certain CAD, it's very hard to give you all of the CAD software, everything about this CAD software during this 1.5 or 2 hours. However, we will give you the introduction, and we will give you the basic ideas about these CAD softwares. Then if you need to learn, you can refer back to the instructor, you can refer back to the presenter, you can download the CAD software by yourself. Most of these CAD softwares are free for students. I know AutoCAD, Fusion 360. I'm not sure about SolidWorks and CATIA, but I know that AutoCAD and all Autodesk products are free for students for 1 year, and it can be repeated every year. Okay, so let me start by defining CAD. What is CAD? Simply, CAD stands for Computer-Aided Design. And in other words, it means using computers in creation, modification, analysis, and optimization. These are the main 4 ideas behind using a CAD software. You need to create a product, so you start with using a CAD. Then you need to modify this product after testing, after, for example, the meeting, or after any, let's say, insights from others. You need to modify. So you should be able also to modify this product. Then you need to analyze the product. You can add a material, or you can make a stress analysis, or whatever. As you can see on the right, people who are familiar with CATIA, this is a drawing for a jet engine, and it is assembled all with the fans, compressors, turbines, whatever included in the jet engine design. And you can see that it is very detailed drawing. So the person who did this, actually, he made each product alone, and he assembled them using the CATIA software, which is very strong software for solid modeling. Okay, but why are you using CAD? Before some time, I don't think you remember, I think the older people can remember Engineer Hussam and Engineer Haider. Most construction companies were using blueprints, and blueprints are very hard to work with. They need much space, actual space, not a computer or memory space. Actual space, you need a large space. You need also a certain kind of lighting. If you remember the blueprints, it's also using a certain kind of ink, and printing on the blueprints is not healthy as you think. It's a very complicated procedure. So this is the idea behind Cad Softwares. We are using Cad software for improved efficiency, improved design quality and productivity, and better communications. Now, improved efficiency means how many accurate drawings can you make within a certain time, within a day or 2 days or a week or whatever. Improved design quality means that you can do better designs. You can make a design that is very accurate and that gives much details about your product. Increased productivity is also related to cost, and it's related to the ability of doing multiple drawings at the same time. Now, better communication. Suppose you are an engineer and you need to communicate with your fellow engineer about a certain drawing. Which is better? Which one is better? To give him a CAD drawing or to start drawing for him? And if you get any feedback from him, you have to do it from scratch. You have to use an eraser and you have to all do it in the old-fashioned way. At the same time, once you have multiple CAD drawings and you're, for example, part of a certain company, you will have a database, and this database can be easily accessible from all your engineers or employees. They can go for that database and check all their designs, all their manufacturing designs and drawings. And this is very important in the creating a better work environment, an easier work environment for all your employees. Now, for the intellectual property, which is very important, you need to make sure that nobody steals your work, and this can be done. This can be done easier in the CAD software compared to the actual blueprints or hand-made drawings. CAD applications are many. Some of them are. These are some of the CAD applications. CAD softwares can be used in aerospace industry, in architecture, in automotive, in cartography, in civil engineering, in fashion, in interior design, and in landscaping. So you should not be an engineer in order to use a CAD software. Even fashion designers and interior designers and landscapers are using CAD softwares. And this is the philosophy behind the AutoCAD free license for all students. I know some softwares, they have to verify that you are a student and studying a certain major in order to give you a license. However, the philosophy behind the Autodesk giving you a certain time, I think it is 1 year renewable. You have to verify that you are only a student. They don't care about your major. So if you are an art student, engineering student, medical student, you can get the access to CAD software. This is shows that they believe that CAD software can be used in any field, not only for engineering or aerospace students. So that leads us to the types of CAD used. Currently, we have 2D CADs, which make flat drawings of products and structures. You have something called 2.5D CAD, which is between 2D and 3D CAD. It makes prismatic models, and this is something like, for example, cube, something like sphere, yani basic CAD or basic drawings. You have also the 3D CAD, realistic models of design objects. You have the 3D wireframe and surface modeling, a skeleton-like inner structure of the object being modeled. And this is like AutoCAD 3D that we will discuss today, inshallah. And you have the solid modeling softwares, such as NX, Siemens NX, CATIA, SolidWorks. All of these are solid modeling softwares. And actually, I selected the Autodesk AutoCAD for you today to appreciate some parts that are very hard to make using AutoCAD and very easy to make using solid modeling software such as CATIA and SolidWorks. So AutoCAD is using the wireframe technology, and you have to make sure that you make a 2D graph, then you can extrude it or whatever you like. Now, in most solid modeling softwares now, you can insert a certain model or 3D model directly. If you, one of the most basic solid modeling softwares, and I think most of you are know or are familiar with this software, is TinkerCAD. And TinkerCAD, you can directly insert your sphere, pyramid, whatever you like. It deals with the solid. So think of this as you need to create a 2D wireframe, then you can work on it, or you can insert or make certain features using a solid model directly. So this is the main difference between AutoCAD and other softwares in terms of 3D. Let's talk now about the CAD market. In general, we have North America is the largest market for CAD softwares by region, and Asia Pacific is the fastest growing market by region from 2020 to 2030. So this is the projected numbers. For the global 3D CAD software market, you can see on the graph on the left that manufacturing and automotive are the main market for CAD softwares or the main applications. Others include media and entertainment, healthcare, and architecture and construction. AEC stands for architecture and construction. In 2020, the total CAD market was almost $9.5 billion, which is very large numbers considering that these are still softwares. So these numbers makes you appreciate the CAD market, which the softwares are already used in these markets, and new markets are opening for using CAD softwares, such as fashion design, such as in many other markets are using CADs nowadays. 3D printing actually enhanced the CAD market since the beginning of 3D printing. If you can see this graph to the right, you can see the US 3D CAD market. It is almost $2.5 or $2.6 billion in 2016, and it is increasing. And these are the projected numbers in 2028 to be almost, I don't know, but it seems like it is 1.5 or 150 of 2.5. I think it can go to $4 billion. So the dark color means that it is on site or in premise, and the blue one means that it is on cloud. So you can tell the difference between the actual on-site CAD usage and the cloud usage. Okay, so what are the main CAD softwares available and which one is most used? You can see that SolidWorks have almost 22.7% of the CAD shares across the world. So most of the solid modeling softwares or companies or governmental agencies are using SolidWorks, followed by AutoCAD. And you can see that there is a huge gap between SolidWorks and AutoCAD. So if AutoCAD is using 10% of the market share, or if AutoCAD is having 10% of the market share, SolidWorks is having 20%, which is more than the double of the AutoCAD share. However, AutoCAD is not the only product of Autodesk. You also have the Inventor, you also have the Fusion 360. So if you add the Autodesk products together, so this is almost 10%, this is almost 7%, you can see that Autodesk is having a larger share than SolidWorks. Other CAD softwares include Rhino 3D, Google SketchUp, BobCAD, FreeCAD. I'm not familiar with all of these softwares. You can see CATIA is 1.2. I think this is related to pricing. And I don't know if there is a student available license for CATIA. So you can see that there is a certain market share and there is a criteria for selecting the right CAD for you. So how can you select the right CAD software for you if you are a user or if you are a company owner or a certain company that you need to use a certain CAD. And it's not easy to decide on the CAD. I have seen many companies that transfer from CAD or switch from CAD software to another. And it's a very complicated process because you need to train your employees, to train your engineers to purchase a new CAD, send them for training, and have the product. And the problem with CAD, let's say, when you learn a certain CAD, it's very hard to start with another CAD because even your fingers or hands movement are used to that CAD, especially for AutoCAD. If you are using AutoCAD and you switch for another software, it will be very hard for you to adapt at the beginning, and it can be like a certain period for the company or for the agency to like have less products or have less productivity compared to the standard way or standard. So how can you choose the right CAD? First of all, let's assume that you are a company owner and you need to select the right CAD for you. So first of all, you think about the efficiency of your employees and the efficiency of the CAD software itself, or even the efficiency of your computers, the efficiency of your desktops. How can you adapt for that CAD within the servers that you are having? This is all related to the efficiency. Compatibility is very important also. You are not alone in the world. You are part of a company, and this company is part of a certain, let's say, industry. So you have to provide something worthy for the industry, and this something has to be compatible with the used softwares there. So maybe you are delivering an AutoCAD file and you are submitting for your client AutoCAD files. These AutoCAD files should go into another process. Your architecture, for example, it should go for the mechanical, electrical engineer who has to add some features or use it for something else. So your file or your product should be compatible with other softwares as well. The drafting tools is also important. How you make the draft, the menus, the main workplace, and all these are very important. And even the colors are important for selecting a certain CAD. I know some people who are using AutoCAD. Once they start for the AutoCAD, they go directly for the background and they change the background color from, let's say, black to white. So all these are very important steps in selecting your CAD software. And the most one, I think, in my opinion, the most important one is pricing. So some softwares are very expensive to have or to get the license. And this makes them very tight, or the usage of these softwares are very tight, and they have special usage for example, let's say, so it can be used in a certain industry. And lastly is the support availability. I think Autodesk are having excellent support for the users, for the owners, for the companies, and for many other people in the industry. And I know that other softwares are trying to do their best also in terms of support. And this is the way how you choose the right CAD software. And always try to avoid. I remember in a company I used to work with, they switched from AutoCAD to another software called Bentley MicroStation. I've never heard of this software before. It's called Bentley MicroStation. It was very hard for the draftsmen and for even for the engineers to adapt for this software. AutoCAD has a certain secret that you can use the keyboard and the mouse at the same time. Other softwares, you can only use the mouse or the pad. So people who are using AutoCAD are, let's say, very loyal to AutoCAD because they know the commands and shortcuts since a long time ago. So, I'm telling you this as a professional CAD or AutoCAD user. These are the one of the most things that keeps you using AutoCAD, because with versions coming on like 2016, 17, 18, you don't care about the version. You don't care about the line command in which menu it is now, because you already know the shortcuts. So once you know the shortcuts, you can use any version of AutoCAD. And I will show you what I mean in the once we go for the hands-on experience for AutoCAD. Now, Autodesk company is founded in 1982, and it provides software products for architecture, engineering, construction, manufacturing, media, education, and entertainment industry. If you look at this picture, you can see that these are some of the parts of some of the products of Autodesk, not all of them. So you can see that this is AutoCAD, AutoCAD LT, Fusion 360, Inventor, Revit, Autodesk, 3D Max. So all of these they are very popular softwares, and all of these are under the AutoCAD umbrella. Okay, so this shows you the market share or the earning of Autodesk from 1999 to 2014. So this is very, and it can be from my own experience. I can tell you that at the beginning here from 1999 up to 2003, it was the first, or it was the beginning of having AutoCAD and using AutoCAD in many industries. Now, since AutoCAD was almost the only software here, you can see that there is a sharp increase in using AutoCAD up to almost 2008 and 2009. In these years, I think that other softwares started to compete in, let's say, in a good way with AutoCAD. So the effect can be seen here with the sharp decline here in almost 2008. Now there is increase here, and this is actually very interesting because Autodesk after this, or in this area, or in this era, let's say, Autodesk started to produce another softwares related to AEC or architecture and construction, and this can be like Autodesk MEP, Autodesk BIM. Now most architecture and construction industry are using Revit, which is also under Autodesk. So it is very let's say close to AutoCAD in terms of usage. However, it gives you better results and good coordination between multiple, let's say, disciplines such as architecture and mechanical, electrical, firefighting, HVAC, plumbing, water supply drawings. So this is I think this is the reason behind starting to increase again in almost 2010. So let's talk about AutoCAD. Today we will have a hands-on experience. I will start AutoCAD and show you some, let's say, simple drawings. AutoCAD started in, I think, in 1982 as well. The first version was named AutoCAD 12 and AutoCAD 14. I remember I learned AutoCAD 14 as the first CAD software in my engineering life. So then it was, I don't know why did they change the naming from AutoCAD 12, 14, then AutoCAD 2005, AutoCAD, sorry, 2004, then AutoCAD 2007, 2009, up to AutoCAD 2022. Now, the applications of AutoCAD include architecture, civil engineering, interior design, automobile industry, aerospace, mechanical engineering, and fashion design. If you look at the left picture here, you can see this is the first or the ground floor and first floor. This is an architecture plan for a certain space. I think this is a flat or a villa. You can see the bedrooms here. This is a wall, the blue one. The red squares here are the columns. You can see also here you have the stairwell. These are the doors. These are the windows here. So it is an architecture plan done using AutoCAD. Now, if you look at the second one here to the right, this is an MEP drawing. This is actually a drainage plan for a certain, how can I zoom here? Okay, this is a drainage plan for a certain building. So as you can see the pipes and you can see all the drainage components, floor drains, clean outs, whatever. Now, the interesting thing is the drainage plan is drawn or made on a reference for the architecture plan. So simply, what happens here is that the drainage engineer, for example, or the drainage draftsman uses the architecture plan as a reference. So he goes back to the architecture plan and bring it to his own screen, and it will be like a picture. It is a read-only picture. So now he can make his plan based on that plan or based on the architecture plan. And this is a good way of doing work, because if the architecture makes any change, it will be reflected directly on the mechanical or the electrical engineer directly. So this is called the reference, or how you use the reference in AutoCAD. In AutoCAD for multiple disciplines such as mechanical, electrical, civil, and whatever. Now for AutoCAD, as you can see from these small pictures, you can use it for architecture tool set. Actually, there is AutoCAD, yes, AutoCAD, there is AutoCAD electrical, I know. There's AutoCAD MEP, I know also. There is AutoCAD LT, MEP for mechanical, electrical, and plumbing and firefighting. Also, there is AutoCAD Web and AutoCAD Mobile application. So the integration of AutoCAD is very large. So can you get a student license? Yes, if you go for this link, autodesk.com education students. If you are a student or educator, you can get a license for 1 year for Autodesk products. Now, after 1 year, your license will expire, so you have to renew your license. You have to provide supporting documents. For example, for me as an educator, I provide my university ID, a picture of my university ID. However, for a student, you can provide your transcript, for example. You can provide a letter from the university stating that you are a student, or whatever document that you can do it. You just submit it to the using the website. You make you need to sign up first, actually. Then you need to make a username, password, whatever. You provide some information. Then you have to provide your supporting documents. They will check it. I think they may like a few hours or up to 1 day. If it is not a holiday, for example, avoid to do that on Saturday and Sunday. If it is not a holiday, within a few hours, they will reply to you and send you the license. So this is my presentation for today. And now I need to go for the AutoCAD software. I will show you how to do a simple drawing in 2D, then we can do another drawing in 3D. I hope this is beneficial for you, and thank you very much. Okay, so let me start AutoCAD now. Okay, so I need to share. Okay, can you see my screen now? Can you see my AutoCAD screen now? Okay, very good. Okay, very good. So once you open AutoCAD, you need to start your drawing, or you need to open a file. So it gives you this menu, get started, so you can start a certain drawing. Now, usually, if you go for new, it gives you some templates. So if you need to make a certain, if you are familiar with these templates, but if you are doing a drawing in 2D, you can use the acad.dwt, or you can use acad 3D.wt for a 3D drawing, and you can switch in between. So let's start for the template for 2D. From here, you can switch between drafting and annotation, which means that you're doing this in 2D. 3D basics, look how the it's very similar, and you can go also for 3D modeling. Okay. Okay, so let's, for example, we have this. If you look at the menus here, the menus will be changing when you go for another, for example, system. If you go for 3D basics, you will have another menu that's related to this drawing, for example. If you go for 3D modeling, you will also have a new windows or a new commands that's related to this kind of product design. So let's go back to the drafting and annotation, and let's start a very simple drawing. Okay, so this is the screen or the background or the drawing screen for AutoCAD. This is your workspace. You can see these lines here, they are called grids. You can switch them on or off. Okay, so these are the grids. Now, this is your axis, X and Y axis, and this is your, let's call it UCS or WCS cube. So you can go within the cube, you can see the top, you can see the front, you can see the left, whatever. Okay, so here, this is our XY. So if you need to draw a line, for example, you can go for the draw menu and select line and make a line. And it's very interesting here that for, let's say, ortho line, let's call them ortho line, means that the lines that are even horizontal or vertical. So you can just click here, click anywhere, then you can go with your line. If you need it to be horizontal, it gives you that it is, for example, its length and the angle here. Okay. If you need to make it vertical, it gives you the angle here, either 90 or 270. Now, if you need to make a certain line with a certain angle, you just write it. And if you go and check what I will be writing here in the bar, this bar, the line specify next point, or I will write, for example, at 100 angle 70, for example. So this is my line now. You can make a line with an angle of 70 and a certain length. Now, people who are doing AutoCAD, usually, if they need to make a line, they just press L on the keyboard. So as you can see here, L is a shortcut for line. Or if you forget about the shortcut, you just can type line. Please look at the command here. I just typed line. Okay, enter. Then you can make your line. So this is how I am telling you that people who are using AutoCAD or familiar with AutoCAD, they know all the shortcuts. So they don't care if the line command or not the line command. The line command has been always in the draw menu. But for other commands, if they change the command, let's say menu, if they change the command location, they don't care because they have they know the embedded shortcuts for AutoCAD. So if you need to make a line, for example, if you need to make a circle, you just go for the circle here and make your circle, or you can press on C, then enter. So you can see here that C is for circle. You can make your circle. Okay. If you need to trim, you can trim these spaces. However, I trim using the command TR. So TR, look at the bar here, the typing bar. TR is for trim, so I can directly trim my line. So this is why AutoCAD is so easy. It has these embedded shortcuts, and it saves much time and effort, especially when you are used to it. Now, if it happens to me once when I switch to another software, I don't know what to do with my left hand. So it was only by mouse. So you can use that software only by mouse. So you don't know what to do in your with your left hand. You are used to type with your left hand, type the shortcuts with your left hand. However, the other software or the new software does not have these shortcuts. So have to do your hand. It makes a stress for your hand. It makes a stress, and I think it will start. Yes. Yes.
We couldn't hear you.
Okay. Now, is it better now?
Yes.
Okay. Okay, very good. So let me make a very simple sketch, for example. Let me make a spanner. You know the spanner? I don't have actually a reference drawing, but I will make it something like this. So I will make a line here. Before that, let me check the units. Now, if I need to go within these menus and look for the units, I will be lost. So what I need to do now, I just write units. It opens the units menu. So I need to select, for example, millimeters. So this is millimeter. Now I'm doing all my sketches using millimeters. Let me start with the first thing to do. Let me start with a circle. And now if you look at this bar here, circle is specify radius of circle, or between brackets, it gives you diameter. So if you need to switch from radius to diameter, you just press on D. Now you need to enter the diameter. Okay, so let's assume that the diameter here is 36, for example. Zoom, extend. Zoom is Z and extend for E. So this is zoom, extend. And as I told you, I am very familiar with the shortcuts. So now let me make another line from the center of this circle. So if you go and try to approach this circle, it will give you a certain snap, which is the circle center. So I will make it as 100 millimeter. Now, if you are familiar with a spanner, the spanner is having a certain opening, and this opening is, let's say, having a certain angle. So I can say, for example, I need this angle to be something like this. So I don't know what's the angle size. I can make this line at, for example, 50 angle. 180, so let's make it 200. So this is your angle. Okay, now let's make the opening. I need to offset this line with half the opening upwards and offset this line with half the opening downwards. So let's say that the opening is something like 16 millimeter. Now I need to offset. I just pressed on O, and this will make the offset. I provide the offset distance. It is 8. Then I select this line and make the upper offset, and select this line and make the lower offset. That's it. Now let me connect these two lines together with a line. Okay, now I need to make a fillet between this line and this line. You can take or get the fillet from the modify menu. This is the fillet, or you can just press on F. Please always look at the bar in the bottom here. It will show you the everything you are working with is here. So I need to specify the radius now. If you check here, you can select the radius, or you can just press on R and it will go for the radius. Let's assume that the fillet radius is 5 millimeters, so you can make a fillet between this line and this line. Now in AutoCAD, if you press enter, it will repeat the last command. So I will make another fillet between this line and this line. Okay, now let me trim. I can use this trim. So I will trim this line and this line as well. These lines are not used anymore, so I can remove them. Okay, so this is the spanner handle. So let's make the handle to be like 10. So it will be 20 millimeter in width. So this means that we have to offset this line by 10 upwards and 10 downwards. Okay. Now I need to make a circle here or a fillet, but if you make a fillet here, it will not be successful because it will take the rest of the circle. So it's better to make a circle, a full circle here, then try to trim it again. So let me go for the circle. I press C here, enter. I have the circle command. Now I don't know where is the center of the circle, but there is very interesting feature in AutoCAD. You can draw the circle even if you don't know the center using a command called TTR. See, look at the TTR here, TTR, 2-point, 3-point circle, you specify 3-point and it will make your circle. 2-point, you need to specify 2-point and it will make your circle. TTR or tan radius, you have to provide a certain tangent for the circle, another tangent, then you specify the radius. So let's try it. I will type TTR. I need the circle to be touching for this circle and this line, tangent to both of these elements, and having a radius of, let's say, 5 mm. So this is my circle. I can repeat the same command and do it for the lower part with the same radius. So I have a upper circle and lower circle. Now it's time to trim the excess. This is excess. Now this is excess as well. This is excess. Now let me zoom a little bit. I am zooming with the my mouse scroller. So this is excess now. This is excess. Okay, I'm sorry here. So I have one side now. Okay. Now I can start with the other side. However, if I need the two let's say sides to be the same, and this is usually not the case. The two sides are not the same. Yeah, there is a certain difference between the opening or the curves here. However, let's assume that we are having the same sizes for the two spanners. So I can copy this. Okay, without these, I don't need these. Okay, I can copy this, for example. I will copy it. Huh? Okay, I can copy now. So how can I copy? I can use the copy feature here from the modify, or I can just type CO. CO means copy. Then I can take it here. Okay. Then I need to mirror this. I need to mirror this. I just select it. Then you can also use the mirror command from here, or you press MI or type MI for mirror. So this is my mirror now. This is Ortho Line, which means that this is a perfectly vertical line. You can mirror your. Now it gives you an option. Do you need to erase the original? If you look at the bar at the bottom, mirror, erase source object, you can select yes or no. So I need to select yes, I don't need it anymore. So this is my object. Now I need to mirror it again. However, this time I need to mirror it vertically. So I can use the mirror command again. And this is my product. You need to erase the source object, yes. Okay, so I have the other side of the spanner now. I can move it back to this point. I can move using the command move here, or I can just press on M, type M. Again, look at the bar at the bottom, move, and I will go and select this point and put it here. So I have now a perfectly drawn spanner. Okay. Was it hard? It may be hard for the first time, second time, third time. However, once you are experienced with all of the, let's say, commands, it will be very easy. It will be a piece of cake, but you have to practice. AutoCAD and mostly all of the softwares, any softwares, even if it is CAD software, programming software, there is also always hidden features. And if you need to learn about these hidden features, you have to read plenty of books, or you can just go and practice. Once you practice, you will always find something new. You will always find something worthy for your convenience. Okay? Type. So now let me switch. I can take this as actually, I can take this, or I can make a new drawing. So let's switch for AutoCAD 3D, and let's have some, let's say, modeling for some parts using AutoCAD 3D. So let me open a new, and let me go for this template, AutoCAD 3D.dwt. Okay, so this is the AutoCAD 3D. This is how the AutoCAD 3D looks like. Okay, now I can copy this. I don't know if I can take it here. Oh, sorry. Okay, I can switch directly to 3D modeling here. Now I need to give it a thickness, a certain thickness for this spanner. What I need to do, this is very interesting button, is the press pull command. The press pull command just gives a thickness for your feature, whatever you like. So you can make it like 10, for example. I think 10 is too much. We can make it like 4. Okay, so this is our 3D model now. And as you can see, it consists of a wireframe. So can we change it? It's a wireframe. So it is very hard to look into this spanner in this form. So you have to go for view and select another types of view. You can go for conceptual design, you can go for realistic, and you can go for example, shaded. So this is your spanner. You can change your view SW isometric. You can go for another view SCI isometric and whatever. So there was a little challenge in doing the 3D model. However, it was a bigger challenge in doing the 2D model than to extrude it or to press pull it into a 3D object. Now, what's interesting here is that you can also in other softwares, yes, it's doable. What interesting here that you can add a certain material for this spanner. So if you go for the material browser here and select or look for some metals, you can see these are some kind of metals here, aluminum, for example, and you can select your product. And for example, add a certain material to your product. So This is how it looks like when it is aluminum. This is the, for example, another materials. Yani you have a library of materials here, and you can select multiple materials here. Okay. Okay, so here you have, if you press on your scroller, you can change the location. You can go within the screen anywhere you like. If you see the cursor here is 3D, you have a 3D axis here. It is WCS or WCS. Here you have the rotation block. You can select left, for example. This is home. You can select the top, or you can select the left, or you can go between them and rotate between them, as you can see from here. Okay, so let me add another material. I didn't like this color, so let me go for metal. I need to select this, then I can go for this metal. Okay, I think this is better. Now I have some features here controlling the lighting, the shadows, and the sun status and the sky. These are from lights menu and the sun allocation menu. Lighting means that you need to create a certain lights. You can have a point light, you can have a spotlight, you can have a distant light, and you can have a web light. So let's use this one, for example. Allow distant lights. And you can see also the sun status here. Here you can see that there is no shadows. You can select, for example, ground shadows or whatever you like. Now this is not arbitrary. You need to create a certain product, and you should be familiar with this lighting and whatever here. You should be familiar with it. Then you can create a render. You can start rendering from here. If you press on the rendering or render to size, you can select your resolution. So let's go for this resolution, for example. Okay. Then let's press on render to size. Okay, so this is your product based on the lighting that you just have done in your features there, in the lighting features. So if you go and select a certain lighting, I turn off lighting, then you can turn off no shadows, whatever here, you can turn it off, whatever. Then you can go for rendering again. You can see that it is different because you don't have any lighting here, and the material color is very dark. Here you can also add a certain background. You can have a sky background. Then if you render again, you will see that there is a bright background for your product. Now here you can add illumination, for example, sky background and illumination, and you can see that it can be different in a certain way depending on your let's say view, and depending on your features controlling that view. Okay, so let me add another drawing, or let me make another drawing. I don't know how to okay. Let me switch here for the drawing number 3, and I will insert a certain drawing here. This is my reference drawing that I'm going to make. Okay, 1 minute. Let me bring the drawing to the CAD. Copy. So let's try to make this drawing. So as you can see, we have 2 circles here. It has different heights. We have a key slot here, or key opening, or keyway here, and we have a wedge here. Okay, so If you look again, you can see that the first circle is having a diameter of 64. The second circle or the inner circle is having 36 diameter. These diameters are 42 and 24 in diameters. Now the distance between the two centers is 100. Okay. Now we have this line here. It is tangent to this circle and tangent to this circle as well. And the second line on the other side is also tangent to the circles from the other side. So let's try to make the 2D drawing of the base. Then we can extrude it upwards and see what happens. After that, we can add the wedge. Then we can add the keyway here. Okay. So let me open a new drawing here. And I think we have to switch for 3D modeling. Okay. Then we can go for home and select the world UCS, which is your axis here. As you can see, this is X, Y, and Z. You can switch your axis to top. You can see it here, top. See the axis now is, you can see the axis is switched. X in this direction, Y and Z in the other direction or in the upper direction. You can go for left, for example, and you can see that you have a different axis now or orientation for the axis. So let me start with the world. I will select a view of, let me check the drawing again. Okay, so I will select the best view for this drawing is SW isometric. Then I can start my drawing. I need to make two circles. So C, look at the command window below. C, enter. I will make the first circle. So this is my first circle. But before, I did not check the units. So let me check the units. The units are in inch, so I can convert them to millimeter. Okay, now we can start with the first circle. So the first one is diameter 64. Now, if I select 64 or write or type 64, it will make it with a radius of 64. So I have to change here. If you look at this bar, diameter in brackets. So I can type D, it will go to the diameter. Then I can make it in 64. This is your first circle. I can now make the other circle. I think the diameter was 36. So I can make another circle here. I press C, then enter. I go up, try to approach the circle line, and it gives you the center here in order to make sure that they are concentric circles. So now I need to press D to switch for diameter and make 36. Okay, so this is my first part, which is here. The first circle, which is having the 12 millimeter keyway. Now I need to make the other circle here, which is having the 42 and 24 millimeter keyway. So I can make a line now. And this line should be 100. Okay. Very good. Now I can make the other circle, the smaller circles. Let me go back and check their size. The first one is having 42 millimeter diameter, and the second one is having 24 millimeter diameter. So I can start with the first one, C, enter for circle. Then I start my circle. I need a diameter of 42. So I just type 42. Now for the other circle, the diameter is 24. So, circle D24. Okay. Now, this is my base. Still, I need to make the lines which are, or the tangent lines between the two circles. Okay, I can complete my drawing here, or I can switch for the top here. I did not change anything with the axis or the UCS. I just يعني I just asked AutoCAD to rotate the drawing so I can see it from the top, then I can complete my drawing. So I need to make a line which is tangent to this circle and tangent to this circle as well. And another line which is tangent to this circle and tangent to this circle. I don't know the actual length of this line, but I know that it is tangent to the two circles. So I can go and select a line or press L, it will give me a line. Now if you go here, it will not snap to the tangent. It will snap directly to the center. So if you start drawing, you will start from the center. So you need a method in order to snap from the tangent here. Okay, this is very important because it is the heart of the AutoCAD accuracy. If you press on Control, then press on the right mouse click, not the left, the right one, you will have this snap menu. Okay, then you can select any, let's say, snap you want. If you need to start from endpoint, midpoint, intersection, whatever, center, quadrant, or tangent. Let me select a tangent here. So tangent, when you approach this circle, it will be tangent to this circle. Then I need to go for the other circle for the tangent. Again, I press on Control and right mouse click, then I select for the tangent. And you can see that it created a line which is tangent to the two circles. Okay, I can do the same. And I previously told you if you press on Enter, you will repeat the last command. So I press on Enter, then I go again, Control, right click, tangent, then Control, right click, another tangent, and this will be your line. Okay, let me rotate this. So this is your object. Now, this is your base. You need to start extruding this base. Okay, so let's go back to this page. You can see that the side is 12 millimeter in height. The lower circle is 24 millimeter, and this circle is 36 millimeter. So I need to, let's say, extrude or give thickness for each one of these alone because each one is having a different height than the other. So let me go back here. Let me remove this line. I need to press pull this area here. See, if you approach the area, it will give you the selected area in blue. Can you see? I am approaching again. You can see that now it is in blue. Okay, so this is my area. I need to press pull or extrude for 12 millimeter. Now you can see that it is having a certain thickness or it gives you the thickness. You can, for example, directly type 12. So this will be your base. Now, the second circle here, you can see that it is 24. So we can do the same here and make it 24. Press pull, 24. And you can do this. I think this is come high, 36. So you can do a press pull here with 36. 36. Okay. Now you have your now you have your base. Two circles, different sizes, and the area connecting these two circles. Let's go back to the drawing and check what can we or what should we do next. Okay, can you give me 1 minute? Please, can you give me 1 minute? I need 1 minute for a family matter. 1 minute. Okay, I am very sorry for this inconvenience, but I had a certain issue I have to resolve. Okay, can you see my screen?
Yes, doctor.
Okay, very good. So let's go back and continue. Now, let me go back to the main drawing. You can see that we have this wedge. Now, this wedge is extending from this circle here up to this circle. So I need to, my procedure or my steps in doing this wedge, I need to make a triangle, this triangle. Then I need to extrude it with 12 millimeter. Then I will bring it and put it here. Okay, but I need to know the actual dimension of the triangle. Now you can see that the height of the triangle is equal to 36 minus 12, which is 24. So this line is 24. Now here, it is 100 minus radius of the larger circle here, minus radius of the larger circle here. So it will be 100 minus 21 here. So this is 42, the radius will be 21. 100 minus 21 minus half of 64, which is 32. So this will be 100 minus 21
47.
minus come high 64 32. So this will be 47. Yes, so I need to make a triangle with a height of 24, length of or base of 27. Then I will connect these two lines together to get the wedge. So but before doing that, I have to select the right axis. I can start drawing here, but I don't know where is the, or where will be the drawing be. I don't know in which axis I am doing, because this is my UCS so far, but I need to check my actual axis. So let me check here. My view, it is called so far unsaved view. This is my front. So I think this is the side I need to start working with. This is my axis. As you can see, this will be X, Y, and this is the extrude direction, which is the Z. So let me start with my triangle. I'll start with line. Okay, so this is my line. This line should be 47. So 4, 7. Okay. Now this line should be كم حكينا 24. Then we can close our triangle. This is our wedge, so we have to extrude it now. We can go for press pull and start extruding. I need it to be 12 millimeter. Okay, so now I have the wedge, I have the product, but I need to transfer the wedge to be here. Type. I need to put the middle point of the wedge on the quadrant of the circle here. So let's try to do it. I will remove the grid. I will move this. So I can go for modify, move. Or I can just press or type M, enter. Then I need to snap. And if you look here, it only snaps to the ends. I can press on Control and enter and snap to the midpoint. So I am at the midpoint here. Okay. Then I need to put it here. Okay. So here you cannot snap directly to the quadrant. You just need to press Control and enter. This is your quadrant and you can put it here. So this is your wedge. Now I can remove this. Okay. Let me select another view to make sure that it's okay. Okay, is it correct? No. It's not correct. We have to also add this height. So let me remove it. Okay, here before extruding. Oh, sorry. Okay, so here I have to add the height of this. So this is, let me go back here. This is 24 minus 12, which is equal to 12. So I need to make another line here. I am sorry for this. I did not see it correctly. I have to select the front here, yes. So I have a line here. It should be 12. Then I will close. Okay, now I can do it again. So this is 12. Okay, now I can move it. Move from the midpoint to the quadrant. Okay. So now we have, let me remove the grid. Okay, so now we have our product. However, if you look here, you can see that, and this is one of the disadvantages, or خلينا نحكي, let's say it is one of the shortcomings of AutoCAD. Now, if you look here, this is touching. At the middle, it's touching. And if you look here, at the middle is also touching. However, at the sides, it's not touching. And you know, because the curve of the circle is going back, so it's not touching. It's only touching here. If you are doing this using a solid modeling software, you don't need to do this step. However, AutoCAD and AutoCAD 3D, which is mainly about wireframes, you have to do this step. Now, I just need to extrude this part here into the circle and extrude the other part here that is not touching into the circle. So let me do it. I need to press pull here. Press pull here a little bit inside. And I need to press pull the second one also a little bit inside. Okay, again. So this one, press pull. So now I have it touching from both sides, as you can see. Now you can change the view and you can check it from all the views you like. This is HW isometric, the closest to our design, and this is another views. It's northeast and this is southeast. Whatever view you need to show, you can do it. Now I think we need to do the keyway. As you can see, the keyway is 12 millimeter width and length, and it has a width of 4 millimeters. So let's try to move or to make it here. But first, we also need to select the appropriate UCS. So I think it is the top. UCS is the most appropriate. I can start drawing now on the top. Now I can make this line. I don't know the length of the line, but at the end I will trim it, so it does not matter. So I have this line. Now the width is 12 millimeters, so I can offset this line. I press on O, enter to make the offset. I can offset this line with 6 from both sides. So I added again O, enter for offset. Now you add the offset distance here, it is 6. Okay, then I can make one here and one here. Okay, so if I look at this from the top, it will be something like this, and these lines are on the top. Now let me connect these lines together here. You cannot. Let me trim the excess here. Now I need to go for 4 millimeters into this direction, so I will make another line, L, enter. Then I can start from here. I can go for 4 millimeters here. Okay, then I can go perpendicular until the intersection of the other line. This is also another. Then I can go here. Sorry. I'll trim again. So now I will make this line from here 4 millimeter. Then I can go here. Then I can go back here. Then I can close it. So now I can remove this line, and this line. I only have this square, and if you extrude this square, it will make your key slot. So let me press polit up to the end. That's it. So we have our. You can remove this now. Let's look at the top. You can remove the circle as well because it is hanging like this. Okay, that's it. So this is our model. I think it is very similar to the model here. Let me check back if it is the same. Yes, it's the same. Now there is one step left. If you remember, when we made the spanner, it was 1 unit. So all the spanner was 1 unit. However, here we have more than one object connected together. So this is one object, this is one object, and this is one object. So we have 1, 2, 3, and 4 objects. So what we need to do is to make them as one object. For this, we use something called solid union. Solid union. Okay, so just press here. You select your object, then you press enter. So now if you go back and you need to select the object, it is 1 unit. You can move it like this. And I can remove this. I don't need it anymore. Okay, you can use another views, for example, SE, and you can use another method of presenting your object. So this is SW. It can be shaded with lines or edges. It can be whatever you find appropriate in presenting your. And this is wireframe. You cannot understand anything from the wireframe. Okay, then again you can go and render it and do whatever you like. You add the lighting, you add the shades, you add whatever you like. So if you go back and let's select a certain rendering here, resolution, then let's see when the object is rendered. You can see that you have shadows here, you have shadows here, you have shadows here, you have certain shadows here, because I left it as the default for the settings of lighting and sun and shadows, whatever. Now, if you need to change it, you can change it, but it does not change arbitrarily. You have to have a solid background in order to create your view or create your object with respect to the background views, lighting, shades, whatever. Okay. So I believe this is more than enough for doing AutoCAD part. Most of the parts are done in the same way, are done in the same method. The principal option makes it very easier for you because it detects the object that you need to extrude. Instead of extruding each part alone, it detects the area between the parts and it can help you in most of your drawing. You still have other options for solids, such as extrude, it's all there, revolve, sweep, union, subtract, intersect, but you can use them. From my own point of view, I don't like to use AutoCAD for 3D modeling. The reason behind this is that better softwares are there for 3D modeling. Even Autodesk provided the Fusion 360 and Inventor, and I think Hussam also, Engineer Hussam and Engineer Haider, also shares with me the idea that these softwares are better suited for 3D solid modeling than AutoCAD. AutoCAD, you have to start from the wireframe and do plenty of procedures in order to do your final product. However, you can do the same drawing in much less steps in SolidWorks or CATIA, for example. The comments are there. And I believe Autodesk is also convinced with this philosophy that AutoCAD is good for 2D and they cannot change it. They cannot change AutoCAD to any other softwares. But the other idea is that they are also convinced that AutoCAD cannot compete with other softwares such as SolidWorks and CATIA. So they created another softwares that can compete with these softwares, and they kept AutoCAD. It has the 3D features, but I don't think that it is used that many or that much with users. Most AutoCAD users are using the 2D part of the software, unless they are doing something special and they can use the 3D. This is my, at least my own point of view regarding this issue. If I need to do this drawing again, I will go for Tinkercad, which is very simple to do it, or you can go for CATIA, SolidWorks. It's not that complicated, but the process itself in AutoCAD may be not that convenient for 3D modeling. Okay, so I was planning to finish at 8, so now it is 8. I hope this was useful for you. I hope you had an idea about AutoCAD in general. We cannot do everything, we cannot explain everything, but at least you can do something in AutoCAD now. You are familiar with the very basic commands for AutoCAD, which is line, erase, fillet, circle, and you have seen that you can create the level of accuracy is high because you can snap to any point you need, and the snapping menu is diverse and it contains plenty of points. So I hope this is useful, and if you have any questions, I will be very happy to answer you.
Thank you, Dr. Asif.
Okay, very good. So if you have any questions, you can ask them, or you can type them in the message bar here, the chat area. So I can see here, I'm looking at the chat area of NX is a product from Siemens, which simply means that generation NX CAD package. Thank you, Engineer Haider. Actually, I did not look at the chat box up to now. Okay, note it will close after class. This is Osama Khatib. Please do it soon. He's talking about the survey. Okay. Don't forget to fill the survey. Thank you, Muhammad Murad. Thank you, Dr. Amna, Sarah, Shamsa. Thank you, thank you. S.A. Guest. Thank you, Doctor. Everything was. Thank you, Doctor. Thank you, Doctor. Thank you, Doctor. Okay, very good. So I hope this is useful for you. Don't miss the next session tomorrow at 6:30 with Engineer Hussam Faraj. And again, I would like to thank him for helping us with the Fusion 360. Actually, Engineer Hussam is teaching this software, and he told me that he's doing also Inventor. So he's a professional user and tutor for Fusion 360 and Inventor. I will be attending as well. And as we said in the at the beginning or in the brochure of the CAD Week, again, if you need to get a certificate, you have to attend at least 3 sessions. So you have to attend at least 3 sessions, and you will get a signed certificate from ASME. And on Tuesday evening, we will announce for the competition, and you will have up to Thursday to submit your file. There is a certain submission folder on Teams, and we will make a certain submission, let's say type file or file type, let's say file type. So it will not it will be common standard for us in order to review it. Then we will meet Engineer Hussam, Engineer Haider, and Khadija to discuss which is the winner for the first prize, the second, and the third. And we will announce them, and he will get a certificate from the dean, and he will get a shield with his achievement, a shield from the deanship of Engineering College. So thank you all for attending, and I would like to see you inshallah tomorrow again for the Fusion 360 session.
Doctor.
Yes.
Thank you, Doctor.
Regarding the competition, is the
Yes.
submission this Thursday?
Yes, submission is Thursday.
Sir, because actually some students have midterms this week, so could we at least like make it a little bit longer till Saturday?
See, Khalid, Rashid, the part you are doing is easy. It does not need that much time. And you will have 2 days. I know that the problem with midterms that we have, it has been also 1 month and we are still doing midterms. I know, but even if we did it for next week, we will also have midterms for at least for myself. I'm talking about myself. I have midterms next week. So this is a never-ending story. So I think it is the time is convenient with respect to the product needed for the design.
Okay, thank you, sir. And sir, Balqis Thani is asking, Doctor, can you tell us more about the competition?
Yes, Balqis, on Thursday, inshallah, after Engineer Haider session, we will announce the competition details. So it will be a certain product. It will be a common product. All of you should, or all people who are doing the competition should do the same product. However, we left a room for innovation and your input in the product. So for example, if we are going to make a table lamp, for example, it is not the competition product, but if you need to make a table lamp, the design of the table lamp, it's up to you. It should be a table lamp, working table lamp with all components, or let's say all the main components. However, if you need to add another component for like geometry, for beauty of the product, it's up to you. It should be a working product. So we will give you the product name, but everything else, it's up to you. The material selection is up to you. The shapes is up to you. You have to provide the products in let's say in product files, the separate files and the assembly files, and we will provide you with all the details inshallah on Thursday. and you will have a professional judging team in order to select the winners. I hope all of you will be winners, but unfortunately we can all only select 3 winners. Okay, Balqis? Any other questions? Yes, you can use any software you like, AutoCAD, Fusion 360, CATIA, SolidWorks, whatever software from the four softwares contained in the CAD Week sessions. You can use any software you like. Now, if you have any concerns or if you have any questions related to AutoCAD or if you have any questions in the future or anything comes to your mind in AutoCAD in the future, you can directly contact me. Okay. I wish you luck all the time and thank you for attending this session. Don't forget to answer the survey so we can know the people who are attending. And I wish you good luck and see you tomorrow, inshallah.